In this lesson, we're going to examine how to graph and write piecewise functions. Let's graph f of x, which you can see is a piecewise function, and hopefully you recognize that each portion of this is linear. So it's going to be made up of two rays, I suppose I could say, because when I look at the constraints, for here x is less than 2, here it's greater than or equal to 2. So they're both going to continue infinitely in one direction. All right, so let's start with x plus 1. My strategy is to take the constraints and plug it in to that portion of the function. So when I plug in 2 to this top part, I would have 2 plus 1, which of course would be 3. So there is an ordered pair, 2, 3, as an endpoint. So I'm going to go and I'm going to graph the ordered pair 2, 3. And if you notice, I put an open circle rather than a closed circle because my values just approach that. They get really, really close to it, never actually touch it. And now you can plug in either some more ordered pairs or use your knowledge of linear functions. So if you were plugging in more ordered pairs, you might want to pick 1, 0, -1, get some more ordered pairs, but I'm going to use the slope. I can tell that the slope here would be +1, so it needs to, of course, go to the left, this direction, because of my constraints. So I'm going to go down 1, left 1, down 1, left 1, to get that slope that I need. So there I draw my ray going infinitely to the left for all domain values less than 2. Now I'm going to plug in, again, 2 is a constraint here, into this part. So this would be -2 times 2 plus 7, which also happens to be 3. So again, 2, 3 is a point. Well, I've already have that graphed as an open circle, but now it gets closed in because it does exist as a value in the second portion of this function. And I am again going to use my knowledge of slope. So from this ordered pair, I'm going to count a slope of -2, which would be down to right 1. And then I will connect it with another ray. And there's my completed piecewise function. Again, it's a function because it passes the vertical line test. Let's graph one more here. And this one, if you look at it, is a combination of a quadratic and a linear function. And this one has constraints that are bounded on both ends. So I am going to plug in both -2 and 1 into this top portion of the function. So when I do, I would get -2, 4, and 1, 1. Now, this one will be an open circle, and this one will be a closed circle because of the inequality less than and less than or equal to. So I'm going to graph those two ordered pairs. -2, 4 will be an open circle, as I just stated, and 1, 1. I'm also going to use my knowledge of quadratics. This is a parabola with a vertex at the origin, since it is the parent function. So I'm going to connect this to make a portion of a parabola. Now the second part, I'll switch colors here, use blue, is linear, and I again begin by looking at my constraints on the domain, and I plug in the endpoints. So this would be 1, comma, when I plug in when I plug in 1, I get -2 plus 4 would be 2. So 1, 2. And this would be an open circle. And then I'm going to plug in +2. So this would be 0. So now I go to the coordinate plane and I place my two ordered pairs, 1, 2, and 2, 0. And again, I know this is a segment, so I will just connect it with this small segment. Okay, again, this is a function because right here, one's an open and one is a closed circle, so it passes the vertical line test. Now we are going to switch directions. You need to write a function for this piecewise graph. So I'm going to call mine g of x, and I'm going to break down each portion of my graph. Beginning with this pink segment, I like to start by deciding where are the domain values restricted to. So it looks like it's between -3 and -1. So I'm going to begin by writing my constraints, and I will consider my inequality symbols here in a second. And I'm going to choose to say that it is less than or equal to, and then less than. And that's because when I name my next constraint, I have to make sure that -1 is not included twice in the domain, or it wouldn't be a function. Now, let's take a look at what our slope is for this line segment. It's up 1, right 1, so my slope is +1. And if this were to continue, it would hit right here at the origin. So my equation is just the line y equals x. Let's move on to this purple portion. So for what values is it restricted between? Looks like it's restricted between -1 and 0. And this time I'm going to say -1 is less than or equal to x, which is less than 0. And this is a horizontal line fixed at -1. So again, pretty simple to write that. Moving on to this greenish teal section. This is restricted between 0 and 2. And I'm going to use the same pattern with my inequality symbols. Now, recognize it's not the only way I could have done those inequality symbols. There are some other acceptable ways. And this line segment has again a slope of 1. The y-intercept is at -1 to make my equation portion be x minus 1. The final segment in black here is restricted in the domain between 2 and 3. So my constraints would be if 2 is less than or equal to x, and I'm going to say less than or equal to 3, since 3 is the endpoint, it won't be counted twice if I write less than or equal to. My slope on this last segment is -1, and where would it cross? +3 if it continued. So this would be -x plus 3. For this next one, see if you can do it on your own. Pause the video and check when you are ready. Function that looks like this is often called a step function. Kind of looks like a set of stairs. This first one is a horizontal line at -5, constrained with the domain between -9 and 0, inclusive on both. Next, it jumps vertically up to -3, but constrained on the domain values between 0 and +3. I just made a small mistake there that I need to fix. This should just be a less than symbol because it's an open circle. My final step has a height of +3, and it's restricted between the domain values of 3 and 9. In this final one, it is an application question. Please pause the video, read through the scenario, and see if you can decide how to evaluate the function. For the first one, h of 67, you are going to need to look at the domain values, which would be 67 falls into this middle portion, so you'll end up substituting 67 into this portion of the function to get an answer of 69, and if I put this back into units, it would be in inches. H of 72 would be substituted into the bottom portion, so I would do 2 times 72 minus 66. So to put this into context, we're saying that if a parent has a height of 67 inches, we are expecting the child to have a height of 69 inches. And likewise, a parent with a height of 72, we're expecting their child to have a maximum height of 78 inches based on this model.